Welcome everybody to our Routing and Switching Essentials class meeting for the week of 221. Well, actually 220, but it's 221.17. And we are going to discuss today some items that we stopped on last week. We were talking about how routers make path determinations. We were looking at how you do metrics and how routing decisions are based upon a metric. And we talked a little bit about how metrics are how a routing method determines the best path. So it's kind of like, again, using the example I had of where we go to lunch or where you go to lunch. The metric of where we decide how to go to a particular, let's say, for instance, a Mexican restaurant. I love Mexican food. We're going to look at, okay, does it have good service? Does it have good food? Does it serve beer? Does it serve good nachos? All of those would be metrics that we use to choose between whether or not we go to one Mexican restaurant versus another. Now, but what if we have two different choices of types of food? So we want to decide, you know, I could either go to Italian or Mexican. And I need to determine which one of these two I would want to go to. And I'm not comparing Mexican restaurants and Italian restaurants. I'm comparing Mexican food to Italian food. This is what administrative distance does. This is how, when a router or a routing device has a path to the same network from two different types of routing sources. All right. So in other words, I've got a route that is a static route, and I have a route that is learned via RIP. Which one of those two am I going to use? It's to the same network. I can't compare metrics because I can't look at the Mexican restaurant and say, okay, compare chips in the Mexican restaurant to chips at the Italian restaurant, because the Italian restaurant doesn't serve chips. So I need a way to say, out of these two, which one's better? Well, Cisco uses a concept called administrative distance. And what they do is they assign a value to routing methods, and then the lower is better in terms of that method. So in this case, if I knew how to get to a network and I had a static route to it and I had a RIP route to it, the static route would be the route that's placed into the route table because it has an administrative distance of 1. RIP has an administrative distance of 120. If I had a route from OSPF and a route from EIGRP, okay, internal EIGRP, the EIGRP route would be placed into the route table. Now, why was OSPF given 110? And it's a shortest path first routing protocol, you know, triggered updates, SPF algorithm. Why is it given a higher value than EIGRP on a Cisco device? Well, because EIGRP was a Cisco proprietary protocol. And so they said that that route via EIGRP is more trustworthy than any route you would learn via OSPF. So, same concept. Will we go to Mexican or will we go to Italian? It depends on which one of those you rank as a better type of food for you. Same thing with this. Which route will I use? It depends on which of these the iOS, the Cisco operating system, and will use to determine its best path. You need to know these numbers. You need to know that connected is 0 and static is 1. You need to know that internal EIGRP is 90, OSPF is 110, RIP is 120. I would probably even throw external EIGRP in there at 170. So you kind of learn those. But these are numbers you're going to see over and over again, and they're numbers that you will need to know as you study CCNA materials and move forward. Okay, so what's the administrative distance of RIP? 120. Static, 1. Internal, 90. OSPF 110. Connected, 0. An external BGP. Ooh, I'm hurting on that one. Somebody help me. The 170 was external EIGRP. Got all those right. It's not 20. 115. Nope. All right, I'm going to go back and look. I didn't have that one committed to memory. External BGP is 20. There we go. So I should have known that one. None of us are perfect. Got most of them. So, but I wouldn't know those. One of the things I also teach my students, if it shows up once in the curriculum, it's important. If it shows up twice and it also shows up on like a drag and drop, it's starting to become something you might want to consider as a possible test item. If it shows up 3 times, you better know it. Okay, so external BGP is 20, and so there we go. So what is in the routing table of a router? Well, there's a couple things. First off, you're always going to have your directly connected networks. So looking at this route or network, the way it is built, R1 will have, at least if these interfaces are up and running, that's important because the router will not put a route into the route table that it can't reach. But for most of the protocols we're working with here, this would have 3 connected routes. And then there may be remote routes, depending on whether or not those routes have been set up on the router or not. Remember, the routing table is held in RAM, okay? And so if we look at the routing table, we can look at R1's route table. And if we do a show IP route, we'll see here that we've got connected routes for the 10 network. And remember, this L is a local or link local route that is the local interface itself. But the 10.0 network's here, the 11.0 network's here, and the 209.165.200 is here, and it's been variably subnetted. We'll also see 2 remote routes learned via EIGRP, and we know that because up here it says D is EIGRP. You also learn later that dual is the routing protocol, routing algorithm for EIGRP. So now, static routes are S, D is dynamically with EIGRP, and again, the good news is if you'll show IP route, you will see all these items here. It's good to kind of put most of these into memory. They're not that bad. We're going to learn about RIP a lot in this class, so you'll learn RIP, which is R. No big problem. Here is a remote entry. You'll see here, this is the protocol it's learned by, the destination network. Now, what's this 90? That's the administrative distance. Okay, and then slash the metric to that route, where it was learned from, how long it's been known, and the outgoing interface to get to the network. All of these items you need to learn how to read so you can say, okay, yeah, to get to this network, I go across here, or I go to here across this interface. Very important to learn those things. Directly connected interfaces, you'll see here, if there are no interfaces up and running, all right, so let me enter my lab here. So I've configured absolutely nothing on this router. This router is in its default state, and it's still booting up, so give it a minute and it'll boot up. But since I've configured nothing, should there be, and you can put in chat or you can raise your hand, either one, if you believe there are going to be routes in the route table of R1 when it first boots up, raise your hand. If you think there will be routes in this router, just boot it up, no configurations on it at all. Okay, we got one hand. Anybody else believe it's going to have routes? Let's go look. Let's do a show IP route. There's nothing there. So there are no routes because if I do a show IP brief, you'll see there are no interfaces running. There are no interfaces up. So there cannot be any IP addresses in the local route table. Now watch what I'm going to do here. I'm going to go into global config. I'm going to give it a host name just because I want to. I'm also going to do a line con 0. Yep, all ports are administratively down. So because of that, there are no interfaces up to have IP addresses in the route table. Now watch this. I do logging synchronous so I won't have junk running all over my screen. I'm going to do interface gig 00 IP add 192.168.1.1.255.255.255.0. All right. So now if I do show IP route, I'm going to have a route in my route table, right? There's nothing there. Why don't I have I just put an IP address on my interface. Why don't I have a route? Well, take a peek. if I do a, well, I got to do it. I'll do it down here. I do show IP int brief. Remember, I didn't bring the interface up. Now, if I do a no shut, now watch what happens. Do show IP route. As soon as it comes up, might take it a second. Look at what we got now. We have a route in the route table to the 1.0 network, which is directly connected on gig 00. I'm going to do this. I'm going to go in here and go int GI, and this is a little bit funny because I picked a weird lab setup for this. Just pull one at random. So, but I'm going to do 192.168.12.1 255, and I know this is a messed up design. Be aware. I'm aware of that. Do show IP route. Oops, got to spell it right. Now look what I've got. I should have two routes in the route table because I have one interface that has an IP address in the 1.0 network, which is gig 00, and I have one that's in the 12.0 network on gig 01. So unless those interfaces are up, and like if I do a shut on this one, so I shut it down, and then do a show IP route, you'll see that that route is immediately removed from the route table. So the interface has to be up, configured with an IP address, and available in order for it to be running and in the route table. Okay. So again, the no shutdown command has to be issued. By default, all interfaces are down, and then you will get your directly connected routes. It tells you it's connected, the network it's going to, the fact it is directly connected. You'll notice there's no AD or metric because the AD is 0. It will tell you the outgoing interface, that the interface connected to it. On newer, now one thing I will tell you, if you ever get a hold of a router that has a iOS that is not iOS 15, you won't have these L routes. Those were new to iOS 15, so be aware if you get a hold of a router like that and you're doing a swap route and you're like, well, it doesn't have L routes, it doesn't have local routes. Well, that's because that was added in iOS 15. So here's an example. I just showed you the same thing. Put an IP address, did a no shut on it, did it on multiple ones, and then you can actually do a show IP route. And on R1, you would see all of our connected interfaces. And then you have the ability here, it will actually, you can type it all in this little syntax checker and do the configuration yourself. Now, IPv6, exactly the same. You go in, put an IP address on it, and do a no shut, and then you will have IPv6 addresses in the IPv6 route table. Notice you do have to do a show IPv6 route in order to get the IPv6 routes to show up. Okay. Now, what is a static route? You'll notice that this particular setup, remember I told you that just because a router has a destination to the route to the destination network doesn't mean there's a route back. Routers always make their routers make their decisions based upon their route tables and their route tables alone. So R1 and R2 may be able to ping each other all day, but they're not able to ping these PCs on the other side because they would not have a route unless you put one in. Now, we can do a couple things here. Now, we can do what's called a default route. You'll notice that this router R1, everything it's not directly connected to, it's going to go to R2 in order to get to, especially the internet, because you've got what's called a default static route you can set up. R2 is going to need routes back to these two specific networks, the 10 and the 11 network. The command to do this is IP route network, the mask, and then either the next hop IP address or the exit interface. Typically, if we're going to do a serial connection, we do the outgoing interface, the exit interface. If we're doing it on a Ethernet, we'll do the next hop and the exit interface, because you're required to do that. But here's a default static route. So if we were on R1 and we want to set up a route that said anything we're not directly connected to, send it somewhere else, we would do IP route quad 0, and then you could do S000, and that would send anything that R1's not connected to over to R2. Then R2 could figure out how to send it somewhere. So here we have the static route. Okay. Right now it's not set up yet. We don't have it set up. I'm going to go in and set it up on R2. Let me see. Did I actually miss something? There's the quad 0 route. Oh yeah, there it is. Sorry. They did the default route going out S000, and you'll see you have a gateway of last resort, S star, connected. Anything it doesn't have in the route table, so any lookup in this table that doesn't exist already would be sent over to R2. On R2, okay, Cronjot. Okay, I unmuted you. On R2, you've got two routes over to the 10.0 and 11.0, and they use two different methods of doing the routes. They did an exit interface, and then they did next hop IP address. Now, here's the issue that you've got using next hop IP address. If you send something to the 11.0 network, so we say 11.10, it goes into this route table, and it goes, okay, I'm looking for 192.168.11.10, 192.168.11.10. And he goes down and says, okay, here it is, 192.168.11. All right, so I've got to go to it via 209.165.200.225. That's next hop IP address. The route lookup process then actually has to go back out and up and find the 209 network. It's called a recursive lookup. So in other words, I found the route, and I know what IP address I need to go to next. But then I have to go back and find how to get to that network, which I can do right here, but I had to do two lookups to make it happen. If you're on a serial interface and you're doing next hop IP address, that's actually very inefficient. You should just do the exit interface, because what happens here, if I send something to the 10.0 network, you're looking for it through here, looking. Okay, here it is. I found it. It's directly connected via serial 000, so they just send it out 000. And the only place it can go is over here, and then R1 is directly connected to it, and we'll do a lookup, and we'll send it over. So even though you can do it both ways, and that's all they're showing you here is you can do exit interface or next hop, on serial interfaces, we typically use exit interface. And then they've got the syntax checker for you to do. IPv6 route, same thing. The default route is : which is all zeros, /0, outgoing interface. So this is the default route for R1. By the way, you do have to have IPv6 unicast routing turned on. So you need that turned on so it will route. So IPv6 route would show your static route. And then same thing on R2, you do two routes. In this case, they did the same thing again. They did next hop IP address, and they also did the exit interface. So they did one as a recursive lookup, one as a non-recursive lookup in the route table. If you look at your route table, you're going to see those static routes inside the route table. And everything works. So those were static routes. So we can configure two types of static routes. One is a default static route, and one is a static route to a network. Now, with dynamic routing, what we're going to do is instead of manually defining those routes, we're going to allow a routing protocol to exchange the information about the networks on a particular router. So in other words, in this case, they're using the EIGRP, and there's a lot of little things going on in the background, but it comes down to this. R1 looks at all this directly connected networks and says, hey, I know how to get to all these networks. 192.168.10, 11, and this 209. R2 would say, I know how to get to all these networks, and I'm also the default gateway to the internet. Now be aware that R1 is going to tell R2 it knows how to get to the 209 network, and R2 is going to ignore that because R2 is already directly connected to the 209 network. But R2 will put the 1011 networks into its route table via EIGRP. So as we go through here, we'll see, EIGRP, router EIGRP, and you're going to learn that we got OSPF, ISIS, we're not going to learn about in this class, and RIP. But we'll learn about all these routing protocols as we continue to move forward. But you're going to set it up. In this case, we see that R1 has learned about the default static route DEX. That's an EIGRP external route. Right now, not the droids you're looking for. Move along. Just be aware that it was this router R1 learned about the default route from the EIGRP. It also learned about the 10110 and 10120, so R2 is advertising these two networks, and R1 learned it automatically. The beauty of a dynamic route is that you can add networks, and they will automatically, depending on how you've configured it, they can be automatically advertised. You also have the ability to respond dynamically to networks going down. So if this 10110/24 subnet went down, R2 could tell R1 about it, and R1 would no longer send information to that. That wouldn't be true with a static route. R1 would continue to send that information with a static route. Now, that doesn't mean that you should always use a dynamic routing protocol. If you've only got one route out, so let's imagine that R1 was never going to have any other route than this out to R2, just use a static default route. There's no need to run a routing protocol. It's just, that would be a waste of time and effort. Dynamic routing protocols also have some security issues. If you don't set up authentication with them, people could join your routing autonomous system and add in their own routes. That's been pretty much nullified by the use of authentication protocols for all modern routing protocols. But still, it is there, and it's something that could happen. Dynamic routing protocols also use more router resources, so you're going to have to maintain the neighbor relationships. You're going to have to maintain what are called topology tables. You're going to have to maintain routing tables. So be aware, run more advanced algorithms. Be aware that dynamic routing does use more overhead than static routing. Now, IPv6 does have its own routing protocols too. RIP-NG, which is RIP Next Generation, OSPF-v3, and EIGRP for IPv6. Just remember this, if we're going to do routing with IPv6, you have to turn on IPv6 unicast-routing at the global configuration prompt. So here's an example. We're going to set up some dynamic routing with EIGRP for IPv6. Just do a show IPv6 route, and you'll see those. And folks, that is routing concepts, chapter 1. Any questions? A lot of content in chapter 1. Huge amount of content. Know all, see all, hear all. All right. I've actually put your dates in for a lot of your activities. I haven't gotten them in for some of your routing for your chapter 3 labs and on, but I do have dates in, and please don't freak out. You've got tons of packet tracers. I know that. You're not going to get all of them done. Try to do about 80% of them if you can. Be aware that I'm also, many of you have not logged into NetLabs and been using our NetLabs class. I'm not going to calling people out right now on class, but let's get in there and start doing our labs. So let's move on to chapter 2, static routes. We just talked a great deal about them already. Why use static routes? Well, folks, the good news about manual routes, they are no overhead, fairly secure, easy to set up, you know, and sometimes just all you need, to be quite honest, especially on small networks. However, they don't adapt well to network changes. They don't adapt well to network outages. They do have some issues in that you could fat finger them and cause a problem. Dynamic routing protocols, more overhead, more resources, but at the same time, they are able to be more dynamic in terms of how your network responds to outages and changes. So here they are, the two little kind of charts on why use one versus the other. I once was in a CCNP test, big test, hands-on test. You know, they wanted all these routing routes and all this stuff, and wanted routing. And I just said, I looked at the network and I was like, well, you could do every bit of this with one default static route or one static route. I put in a static route, they tested it, everything worked, and I looked at them and said, you know, I used one route, right? And they were like, what? I said, yeah, I used one route, and this is how it worked. And they looked at it and said, okay, you're good, because you could understand that, then you knew. But I was able to look at it and say, hey, I don't need all these other routes. I can do it with this one route, the summarized route. So there are some good things about static routing. There are, again, some bad things, so be aware of those. you only got one route out, you're a stub network. If you're a stub network, you only need a default route out. You don't need anything else. In this case, R1 can have a default route going to R2, and R2 can have one route going back to 172.16.3.0/24. Simple. By the way, this is like the third time we've seen the advantages and disadvantages of static routing. I don't know, but when I've seen it 2 times or 3 times, I kind of start realizing that might be something I'll see somewhere else. So I connect here. How to use a static route? We can connect to a specific network, so we can point it to one particular network and the route to it. We can do a stub, or we can do summarization, or what's called a backup floating static route, which is kind of an interesting thing. So let's just look at a standard route. R2 needs to be able to get to R1 16.30/24 network. So we're going to create one static route that goes there. R1 needs a default route out. No problem there. So let me go back here. Does it show it? Doesn't even show it, but it's just quad 0, quad 0. So I do IP route quad 0, quad 0, S000. That goes to R2. R2 would have a route that was IP route 172.16.3.0.255.255.255.0 S000. That's all you need. Network's hunky-dory, everything's going to work great. Now this is called a summary route. Now this is a little bit more complicated, and we're going to talk more about it as we move through summary routes. We'll look at the appendix here in a little bit. But let's imagine that we had this network, and that R1 wanted to be able to get to 172.21, 20, 22, and 23. So 20 through 20, in this case, we're also going to say that 20 is part of this summarization. You can, instead of putting 4 summary routes in, you can actually put 4 routes in, 4 static routes. You can create a simple summary address, a single one of 172.20.00/14, and then that would give you a route back over here. And we'll come back to summary routes later, but right now that is what we could do, a static summary static route. Then we got a floating static route, and what this is, most static routes have an administrative distance of 1. Okay. However, you can actually put in an administrative distance or a metric. Actually, a metric with administrative distance, same thing. It's not the same thing, but in the case of a static route, it gives you a metric of 1 that's higher. By default, metric's 1 or 0, depending on whether it's connected or static. You can change that metric to be something higher than that. And if you do, then it can be a floating static route. So we could do one static route that goes this way, okay, with the default metric. And we could do another static route that goes this way, but give it a metric higher than 1, say 150. And that static route would only be used if this primary route failed. So that's called a floating static route or floating backup route. Now, what is the command for a static route? It is IP route, network address, subnet mask, either the next hop IP or the exit interface, or you can actually do both, okay? And we only do both when we're going out an Ethernet interface. And the next hop is across a broadcast network. Now, again, the distance, that's optional. That configures an administrative distance to change the distance from 0 or 1 so that you can create your floating static routes. So next hop. So here we see R1, obviously, quite honestly, R1 could use a static default route. Everything that's not connected to it goes up to R2. So R2 would need a couple routes. It's going to need a route to 172.16.3 and 192.168.2. And R3 could also use one static default route going out to R2. Okay. So R1, in this case, they decided not to do a static default route. They did individual routes to the 10, 172.16.10, 192.168, and 192.168.2 IP route, and they put in all of those, and all of them are next hop. Now, this will cause what is called a recursive lookup in the route table. If you look in this route table, you're going to see this route right here, and it's the 192.168.20. If you go there, what happens is, because it's got an next hop IP address, and it's extremely hard to see, folks. I don't know why they did it like that. But what's going to happen is it's going to go down through the route table if you're going to the 192.168.20 network, which is over here. See, that's available via 172.16.22. Then it's got to go back up in the route table and find where that network is at. That's why we typically, if it's going out of serial interface, we don't use next hop IP address. We use the outgoing interface. That way you don't have to have that what's called recursive lookup. It goes to the table twice to find the lookup. Now, in the days with our Ceph interfaces, it's not that big a deal anymore, but yeah, it's just good for good common practice. Here we have those routes on an outgoing interface. You see that there's only one, and so anything going to 2.0 would just be immediately sent out S000 instead of having a recursive lookup. Now, fully specified, this again is if you're going across an Ethernet link, you do the route, you have the network, the mask, the next hop IP, the outgoing interface, and the next hop IP address. This is really one of those things that's not used as much anymore because of Ceph, and Ceph is, if it's enabled, it actually eliminates the recursive lookup. So be aware of that. Ceph fixes some of the problems with recursive lookup because it's already got it pre-calculated inside the route table. You don't have to do that. So you also use next hop address if you want to do that across the Ethernet now that Ceph is in place. And remember, Ceph is Cisco Express forwarding. That's a method of forwarding on this router backplane that basically looks at the route table and pre-calculates all the destination paths and outgoing interfaces, and then uses that Ceph table for a lookup. So you never have to go to what's called process switch route table lookup. Verifying route, show IP route, or show IP route static, or show IP route and then the network itself. Or you can do show running config section IP route, and it will pull up just that part of the running config. So some good things there. Default route, IP route quad 0, next hop IP, or exit interface. Same thing. So if you've got an edge router going to the internet, you could go and put it on that. Or if you got a router that it's a stub, has one route out, you can put that route in. So this becomes much easier. IP route quad 0, and this I still use exit interface. And the reason I do it is because what if I have to change IP addresses on these links? I won't have to change my routes, because it's still going to be the same exit interface probably. Show IP route static will show you that static route, and you'll see if it's an S star, then it is a candidate default static route. And we have a packet tracer and a regular lab for that. And then we'll go through our IPv6 route commands. I'm going to move through this pretty quickly because they're exactly the same. IPv6 route, prefix, length, next hop IP, or exit interface. So no real difference. Turn on IPv6 unicast routing, and then you need to set up your static routes. So in this case, let's go in here, show IPv6 route. In this case, there are no routes. They're only connected, so they're showing there's no routes available. And we're going to go ahead and put in those routes. So IP route, the ACAD2, ACAD5, ACAD3, and all of them are the next hop IP address. Could have used the outgoing interface too, because this does cause, probably won't cause recursive lookup, but Ceph. Okay. So no real difference between IPv4 and IPv6 here. Same thing here, you can make it directly connected if you want. By the way, if Packet Tracer asks you to do a directly connected static route, that means use the exit interface. If it does not say to do a static route that is directly connected, use a next hop IP address, and that will help you get the points on that Packet Tracer. So be aware of that. Fully specified, you can still do that IP route, network, prefix, outgoing interface, next hop IP. In this case, it's using the linked local address, which you can do. Again, with Ceph, not really needed. Show IPv6 route, show IPv6 route static, show IPv6 route network, and the network you want to look for. Just put IPv6 in front of your IPv4 commands, and you have what you need. Default static, IPv6, IP route, ::/0, next hop, or exit. No different, folks. So this chapter really is not that difficult. You're looking at here, we're looking at next hop IP address. Show IPv6 route static. You'll see your candidate default, and notice it doesn't have a star. It just says static, : this particular instance. And then you have ping it. Here's our floating static routes. Again, default static routes have an administrative distance of 1 unless it is next hop IP address, which in that case, by the way, if you want to expand the reading pane, you can always do that. You can click here. The reading pane becomes a little bigger. But the default is 1 unless it's directly connected and it's 0. If you want a backup route, you need to know these administrative distances, which have now showed up 3 times. So 90, 100, 110, 115, and 120. So you do your second route with a higher metric than 1. In this case, you're saying IP route _0 go to 22 and send to 1622. Unless that links down, if it is, then install this second route into the route table, which is this route across here. And this route, the second one, because it has an AD of 5, would only go in the route table if this other route fails. So that interface goes down. So by default, it goes there. If that link breaks, then it would go the other way. If you need to test it, just shut the interface down, and you'll see. Okay. You can also do a trace route to see where it goes and break it. Okay. Shut that interface down, and then you can actually see that the other route gets installed. It's kind of fun to do in a lab, play with it a little bit, see it. Same exact thing with IPv6, no different. Just give it a metric greater than 1, and you'll see it. Host routes are just routes that are installed as the IP addresses on an interface. So that's the L. Okay, or you can also configure a host route as a /32 or a /128. Pretty much, if you have one configured on an interface and you're going to have an L, it can be configured as a static host route. And then there's some other methods discussed later in the course, but right now we're not going to discuss those. Okay. Here we see those being installed. Here's a static host route, manually configured to direct traffic to a specific destination, such as an authentication server. So we can actually set up a default route that says IP route to this particular host, okay, /128, outgoing interface, and the next hop link local address. So this is telling the branch where to go for an authentication server is that needs to get to that one particular server. Okay, same exact thing here. We're saying that /32, if you need to get to this one host, go over to here. Okay. So if you happen to get to an authentication server, you had to have a server you could get to, you can do that. So you can put a host route in manually if you so choose to do so. So you'll see here, once the route packet comes in, it's going to go into the route table. It looks in the route table to try to determine if it has a specific route. If it does not, there's a couple things that are going to happen. It's either going to be forwarded. There's 2 things going to happen. If there's a default route set, it will then use the default route. If there's no default route set, then it's going to be thrown in the bit bucket. In other words, if you look through the entire route table on R1 and there's no route for the destination network, that packet's going to get thrown in the bit bucket. Okay. And you can also do things like this, ping this address with the source of 3.1. Typically, if you ping from R1, the source address is this closest interface. So if I did ping 192.168.2.1, okay, then it would actually go out the 172.16. But if I do ping 192.168.2.1 source 172.16.3.1, it sources the IP address, the ping ICMP echo request, with that IP address, which is important because that will tell you if R3 has a route back. I've seen people many times ping from here and not realize they're not actually testing connectivity from their Ethernet. You can also do an extended ping command. Just type ping and hit enter, and you can walk through the commands to do an extended ping. Trace route will show you the route you take across. Okay, and then you can also do a show IP route and begin gateway and look in your route table. One of my favorite commands, show IP int brief. Find out if the interfaces are up and configured. Well, many times you can find the problem by using that. You also can use show CDP neighbors, and that will show you your directly connected neighbors. You can also do show CDP neighbors details, and we'll talk more about this later in the class. You can get more details about your directly connected neighbors. That's something they've added to this class. And I'm just going to let you read these parts because basically you're going through and looking at what the problems are, figuring out that you don't have a route back or a route forward, and figuring out where the problem is. So pretty good stuff there on troubleshooting. Now, folks, that is Chapter 2 in a nutshell. That's it. So we've covered Chapters 1 and Chapters 2. One thing I'm going to do, I am recording all these. I'm going to actually put up the recordings. I found a way to convert them from WebEx recordings to YouTube recordings. So I'm going to put all these recordings on my YouTube channel, and I'll send out, once I get these converted and up, all of our class meetings so far will be up there. It does not show your name. It does not show, you will hear your voice if you ask a question, but other than that, it doesn't show anything on the recordings, so you don't have to worry about any of that. Now, I'm going to stop the recording, and